Hi, I'm Prabhashit, and my uh, index number is MS 198 15374. So this is about the DevOps exam report video, and I'll try to go through the things that I have written in that report. So mainly, when it comes to digitalizing a government-like system, it is kind of a really large scale project, and there should be proper processes and DevOps tools has to be in place in order to make it success. So why do we need a technical stack for this one? Is like it's mainly uh, this type of system. There are many parties are involved for the development because the requirements are rapidly changing because the citizens' requirements are changing and government policies are getting changed. So, and also while uh, there will be new systems to be added, then all the time changes are requirements are changing in this type of system, and those requirements developments those things are done by many different parties, different groups. So, in order to support such a huge development cycle, uh, there should be a proper DevOps tools in place. Like because as per this diagram, we have to design, build, configure, and test and release. So this has to be happen in a never-ending loop. So even a small change has to be pushed and tested. So in order to do that, this deployment life cycle has to be automated as much as possible, and it should be less costly. So then only we can do the multiple iterations without thinking about much. So then uh, that will be straightforward to do, push the changes to production environments with less cost. So due to that, this DevOps tech stack is something mandatory in this type of system. And if we go down further, and yeah, so when it comes to analyze the gaps today we have in this government systems. Normally, if you take examples from Singapore uh, government digitalization project, so they were focusing something about citizens' life cycle events, right? For example, from birth to death, there are many events are being happening to the. So all the recordings have to be recorded uh, throughout the life cycle of a citizen. So, but as we know that um, recording birth related information or death related information or registering the first job kind of, and also the marriage registrations, those different things are being done by different uh, business lines, different departments. So at the moment they might be having their own isolated systems, or maybe they don't have any automated systems. They are running kind of a manual processes. So in order to access them in a central manner, so there should be a central system which should have all these different departments or different business lines work together, and that information has to be managed in a central place or central infrastructure, so where the government can apply or the govern whatever the compliances and all that. So that is kind of a gap at the moment we have, and the solution is kind of to minimize the gap and make a uh, single compliant and governing system which is really accessible to the central government. So Moving forward, yeah, it says about the same story that I was explaining about uh, recording the life cycle events of citizens, but this could be anything. So any requirement which is related by the government, so those systems has to be uh, streamlined into the central system where everyone can develop applications and use the existing services, and the government has should have the facility to persist this information in secure manner in a central place, and control these third-party applications access into that, and accessing in between them. Yeah. So as per the high-level architecture diagram that they have produced, so here we can see bottommost layers. They are proposing kind of a cloud architecture, uh, but it seems to be like in-house data center. Um, Most of the time, this information is kind of confidential to the country, and which cannot be exposed to the outside. Therefore, they are trying to persist them in their own infrastructure. So, but in order to support uh, this infrastructure as a cloud service, cloud platform, uh, we might have to think about a way where we can use them as cloud service. So, for example, in Singapore system as well, they have something called Nectar. They are supporting for the containers with their in-house data centers. So, which is kind of a costly project as I can think. But um, even for Sri Lankan government, if they are proposing uh, cloud environment like this, they can have their own data centers and expose the resources in that data centers to outside as cloud service using open standard like OpenStack. So that is one possibility. Otherwise, if they are um, willing to go ahead with general cloud providers like AWS or Azure, so they can still use it. But there should be another layer like NDIIP where it should control whichever the underneath the platform to the upper layers. So then the upper layers won't see whatever the underneath platforms, whether it's a general cloud provider or their in-house infrastructure data centers. So it doesn't matter. So this layer will abstract that one, and it will provide outside applications in the business lines to deploy the application in whatever the underneath platform. Yeah, so that's about it. And we go down a bit. So in Singapore system also they are sort of at the same thing. They are having this Nectar system, so which will provide this infrastructure for them. And in OpenStack, this kind of the open standard where anyone can be a cloud provider if they have the relevant hardware data centers. So this thing can be managed by the government to provide their own cloud service if they need. So yeah, so this can actually yeah, so this can provide bare metal virtualization or container based different types of cloud services. So that is that. And also I forgot something. So yeah, they have something called Apex in Singapore system. They are trying to provide some central access to the different services among the business lines. So because sometimes one business line has to communicate with another business line, and the users might have to communicate with business lines. Then, in order to control the authentication for those services, they have a central system where the government has the authority to manage these authentications. So that type of thing also needed when it comes to managing different users and between the services. Okay, so if we are moving forward, yeah, so yeah, so there are sort of areas that we have to focus on, like security, usability, when it uh, comes to a solution like this. Mainly security, because and we have something called DevSecOps for um, securing these DevOps pipelines. So in most of the stages in pipeline, the security aspect is a matter, right? From starting developing the application up until the maintenance, security is a matter. So there should be proper tools in place, like to scan the static codes and identify vulnerabilities. And also when it comes to containers, the images are having vulnerabilities because we are downloading those from Docker Hub or something. So those things has to be scan and identify the problems, and uh, uh, let them fix it. And those things are going to be a matter here. And also yeah, and also the existing systems sometimes they might not be supporting to the cloud environment, cloud platforms. So in order to make them support, I think um, they might have to rewrite, to re-engineer. Maybe they are having the monolithic systems. For example, the national identity card registration, they might be having monolithic system. So they might have to re-engineer it and decompose it where it can be easily deployed as a one unit and easily manage it. So that kind of re-architecting part might also be there at the business lines. So that is also one major area. And also when it comes to the success stories, in Netflix earlier they had a huge monolithic system which is having a single monolith of database, and they faced a lot of issues with the single point of failures. As the database is down, they couldn't continue the business. And so then later they analyzed and uh, slowly migrated all their monolith into the microservices. So they are having a really success story, and they have exposed many libraries to the world to use the microservice patterns. So that can be taken as a success story. And they're also using DevOps to manage deployments. When there are microservices, there are hundreds of thousands of different microservices are managed by different teams, and they have to be deployed properly. Most of them have to be automated in the deployment jobs. Testing has to be automated, so those things cannot be done without DevOps. So the usage of DevOps tools, we can list down some of them, like proper source controlling and code analysis, Jenkins pipelines, containerization and container orchestration, like Kubernetes and cloud deployment. So those things. And yeah, so and also the infrastructure as code practices should be followed, because the deployment thing, earlier we had the virtual machines and maybe the bare metal, so those cannot be automated. So someone has to create those instances, and then someone has to deploy the applications. But now creating environment, the container environments or networks, subnets for those environments can be scripted and run. So then the entire infrastructure creation and the deployment process can be coded. So then that code is really easy to manage and maintain. So that is that. And Right. Okay, when it comes to best practices, as we explained earlier, also agile software development, where we can adapt to the changes frequently. We can send small changes to the production. So that is really supported by these DevOps models and the container-based development. So uh, that has to be practiced as a best practice when it comes to DevOps as well. And also the continuous integration and continuous delivery pipelines, the things that I mentioned earlier, and also automated and continuous testing. So the testing part also has to be automated. So we'll come to that later. Proactive monitoring and improve communication. Okay, we'll come to that one by one. So first three parts I think I have covered previously, and if you talk about automated testing, so when it comes to testing, mainly there is something called test pyramid. We have main three classifications like unit testing, integration testing, and functional testing. So usually the bottom part of the pyramid is unit testing, where the developers usually do to test the units whether they are working by mocking the other integrations. So this is the low cost part. We can quickly run and get the results. So this has to be automated, and I mean this unit test should be written for the code. There are measurements to measure those, the unit test coverage. So if you have high unit test coverage, then we can execute them automatically in the pipeline and figure out what is the quality of this code and the unit perspective. Likewise, integration testing and end-to-end testing or the functional testing, those things can be automated using different tools, like if it's Java and Selenium, or in REST APIs, we can use REST Assoc. There are different types of tools, and we can script that automation as well. So then those scripts will be executed automatically when the pipeline is executing. So that's about it. And also the application monitoring, those things has to be in place, like either active or passive monitoring, things like app dynamics or New Relic or Prometheus, those things, where we'll proactively monitor the system or monitor the hardware if it's going to uh, crash, or before down the services it will take actions. So then that's kind of a, resilient and reliable way to keep the systems running. And also the collaboration. DevOps is almost about the collaboration. So development people should know what the operations are doing, and operations should know what developments are going to be done. Then only they can have a collective successful goals. So okay, so then if I try to go through main steps, like how this DevOps pipeline is working initially, uh, if we, yeah, so the developers push their code changes to their feature branches, and feature branches also having their own environment, where it will run the Jenkins pipeline, and it will build the code and run the unit test and run the static code analysis like Sona Cube and all that, and then containerize and deploy into development environments. So then maybe we can automate the functional test suite execution as well, and also developers can do their development test, and once they are ready with that, they can merge into the upper branch, the master branches. Then it will be again run the pipeline and mm, recreate these Docker images and deploy in a staging level environment. So where the QA people will do their manual testing, and once the test is done, and if the feature is ready, then they'll keep until the release. So likewise, there will be many features coming into the release, and once the certain number of features are uh, ready, then they will plan for a release. uh, that release will be again the execution of the same pipeline targeting the release environment. There is one important point in A/B deployment. So there's we have to activate the release. So then only the traffic could route to the new version. So old version is there. It will create brand new infrastructure for the new version and deploy that one. So once everything is ready, then they will simply route the traffic into the new environment. So the new version will be active that point onwards. So that is having the zero downtime. So users won't see whether the system has been upgraded or not. So those things are really cool things in DevOps practices. So yeah, so those are the main. And also when it comes to infrastructure creation, we talked about infrastructure as code, and also there are two types of infrastructure creation: server based and serverless. So in the traditional way, we have the servers, virtual machines, and we have to look at the operating systems, and maybe if the application is a Java application, we have to install the Java runtimes and all that, and then only we can deploy applications. But in serverless architecture, so we don't have anything. We can pull the relevant Docker image, and on top of that, we have our layers, and we have created own Docker image which is deployable. So that is really straightforward, but also we have to think about the security aspects. As I mentioned, the Docker images might have security vulnerabilities. We have to scan them and streamline properly in the DevOps pipeline. Okay, so when we have many number of containers, for example, a system like the government digitalization, we have hundreds or thousands of different containers running. So when it comes to that level, it is really hard to manage them manually. So there should be a way to orchestrate them. So the Kubernetes will manage these containers. They will be having multiple pods, and services will be bounded to different applications, so which will expose the things to the outside. And also the Kubernetes itself is running as a container, and which will monitor this, and it provides all the underlying services to run this thing. So I won't go into detail, but in the document it has explaining most of the relevant parts, right? So yeah. Okay, so then also yeah, so then auto scaling, those things are enabled in Kubernetes, where if you have, depending on the load that you are getting to your systems, it will increase the number of containers and handle that load. So in the off peak hours, when the load is low, then it will automatically scale down, uh, reducing the number of containers, which will save the hardware. So those things are there. And when it comes to the checklist for Kubernetes deployments, availability, so we at least we need to have three containers, three nodes running, so in order to recover from a failure for one node. And resource management, we have to um, properly uh, configure the desired uh, number of containers or maximum, and also the storage utilization. Those things we have to properly configure. And when it comes to security, role-based access control has to be imposed, and also users should follow the proper security practices. And scalability, I think I already talked about this. Cluster might be scalable horizontally and vertically. So vertical scaling is the really important one. We can add multiple containers. So that is called multiple containers or nodes. That is called the vertical sorry, horizontal scaling. Vertical scaling, mainly we have to empower the existing machine or the node with more CPU and more memory, and so it has to be supported for both types, and also the monitoring. So yeah, so those are the main things. And when it comes to the best practices, I think I already talked about this containerization and automation stuff, and also the migration to the microservice based architecture in order to support, in order to gain maximum benefit out of these technologies. Yeah, so those are the main things that I have to highlight. Right. Yeah, so those are the main things. And I use few other references also mentioned here. So yeah, that's pretty much of it. Yeah, thank you.